तो reactivity series के अंदर था कि we arranged them according to the reactivity and we talked about group 1 being the most reactive, फिर group 2 और transition metals जो होते थे they were the least reactive metals, which is why they are your everyday metals. You have copper और इस तरह की चीजें, iron etc. they don't react a lot, react करते हैं but very slowly. अच्छा, so एक तो रिएक्टिविटी का ऑर्डर पता होना चाहिए, यू मस्ट मेमोराइज दिस, ठीक है, दिस इज वेरी इंपॉर्टेंट. इलेक्ट्रोलिसिस के अंदर भी ये बीच में था. नाउ व्हाट यू आर गोइंग टू स्टडी इज द रिएक्शंस ऑफ दीस सब्सटेंसेस with acids. तो reactivity series, the first thing is reactions with acids, and I'm going to write down the reactivity series again. और बारी बारी रिएक्शंस विद एसिड्स हम पढ़ेंगे, जो कि हमने थोड़ा सा पढ़ा हुआ है. मेटल प्लस एसिड हमने we have actually done this. So it's KNA, फिर क्या है, CA, MG, then you have AL, उसके बाद कार्बन, ZN, FE, SN, PBH, and you have CU, HG, AG, EU, and PD. So this is your reactivity series. Now, when it comes to reactions of acids, reactions with acids, तो मैजेट मेटल्स मैंने कहा था, रिमेंबर दोस, it's M to 10, magnesium, aluminum, zinc, iron and tin. ठीक है, these are known as mazet metals and they have normal moderate reactions with acids, but are not too slow, not too fast. So normal moderate reactions with acids. And what is the reaction? It is, for example, if you react magnesium with any acid, HCl, so what would be produced? The H would get replaced, the salt would be produced, and you would have hydrogen gas alongside, and you can balance the equation. So that's your reaction. That's the thing that's going to happen. Mg plus HCl, it's going to produce MgCl2 plus H2 gas, and observation क्या होंगी? There would be effervescence. Okay, as soon as you put a piece of magnesium metal into an acid, या iron, या फिर tin, etc., what you would start seeing is that the piece of magnesium, or for example, this is HCl, so you would start seeing effervescence. So let's say here's your piece of magnesium. One second. So for example, here's your piece of magnesium, and immediately you would start seeing it dissolving, and there would be
So,
bubbles. Walaikum salam. There would be bubbles that would be forming of H2 gas. ठीक है, that is what you're going to see. अच्छा, lead जो है ना, lead that would react with very concentrated acid. 8 से नीचे जो है ना, उनका रिएक्शन जो है वो ऑलमोस्ट होता ही नहीं है. No reactions with acids under normal conditions. या आप कह लो with dilute acids. मतलब गोल्ड डज रिएक्ट विद एसिड्स, लेकिन गोल्ड को ना बड़ा बहुत ही कॉन्सेंट्रेटेड एसिड चाहिए होता है, एक्सट्रीमली कॉन्सेंट्रेटेड एंड करोसिव एसिड, तब जाके गोल्ड ना थोड़ा बहुत डिसॉल्व होगा. बट अंडर नॉर्मल कंडीशंस 8 से नीचे नीचे दे नॉट गोइंग टू रिएक्ट. लेड का भी लिख लेते हैं कि लेड रिएक्ट्स विद concentrated acid only. Concentrated and hot acid. You need, it needs high temperature. अच्छा, और ये जो टॉप वाले हैं, ठीक है, इनका जो रिएक्शन होगा दैट्स गोइंग टू बी एक्सप्लोसिव. सो इट्स गोइंग टू बी एक्सप्लोसिव रिएक्शन विद एसिड्स. ग्रुप वन हमने पहले ही डिस्कस किया था कि ग्रुप वन मेटल्स दे हैव वेरी एक्सप्लोसिव reactions. So it's going to be an explosive reaction with acids. अच्छा, तो this is all about acids, reactions with acids. अब कर लेते हैं, we start with reactions with water. ये clear है सारों को? Noor, is this clear?
Yes, sir.
Uh, अच्छा, so I'm going to talk about reactions with water now. So what's the reaction with water? Let me list down the metals. It's going to be K. It's going to be K and Na and Ca MgAl carbon, Zn Fe, Sn PbH, and then you have Cu Hg, Au and Pd. So now the reactions with water. Okay, we're going to talk about the reactions with water. The first two, a very vigorous explosive reaction with water. Okay, you need to know what's going to happen when they react with water. For example, if sodium reacts with water, so what would happen is it would form NaOH and hydrogen gas is going to be released. ठीक है, H2 gas would be released, and the observation would be कि sodium floats because it's low density. ठीक है, group 1 metals are low density because it's a group 1 metal, floats and fizzes on the surface. It's a very vigorous reaction.
Sir,
Yes.
food reactions with acids, what do you write for PB?
No, what you're going to write is you're not going to talk about PB. I mean, PB will react with acids. It's going to react in in the normal way. It's metal plus acid produces salt and water, salt and hydrogen. Sorry. ठीक है, all of them are going to react. These are the ones in the middle that would react normally.
Okay, sir.
ठीक है, even silver would react, but it would react. I mean, it's not going to have any reaction with dilute acids. It's so unreactive that you would need very concentrated acid for the reaction to happen.
Okay,
ठीक है,
sir.
is this clear?
Yes, sir.
So just remember, metal plus acid produces salt plus H2. And so reactions with water, group 1 metals, they are going to react. They're going to have very vigorous reactions. It might be even explosive. What might have happen is that sodium could melt. Group 1 metals have very low melting points as well. ये हमने पहले discuss किया था. Sodium could melt, and if it melts, it or an H2 gas might catch fire. So you might be seeing a flame with the sodium metal. ठीक है? So just as an example, I just wanted to show you because it would be because if you see the reaction, it's a lot easier to actually write the observation. ठीक है? Maybe some of you just 1 second. Sodium with water. So probably this one. ठीक है, the lab one.
and look at sodium. Like the lithium, the sodium is stored in the mineral oil.
You wait
If we
one
remove
second.
it, we can see the shiny metal under much more rapid
Acha, this
reaction with
is.
and add it to water. We notice a much more rapid reaction with
Acha, so the piece of
the
sodium.
water.
Wait one second. So the piece of sodium over here is floating. Group 1 metals always have low density, so it's floating on top of the surface and it's fizzing and it might melt and might catch
Like
fire as
lithium,
well.
the sodium is less dense than water.
And
It
it's probably going to
floats.
explode at a
The
certain
metal
point.
moves across the surface, being pushed by the hydrogen gas that is produced. As you go down the column with group T,
So just as.
we can test for the fact that we produce.
So that's how sodium would react. Okay, you'll be asked about. I mean, in every paper, you're asked about these observations for group 1 metals reacting with water. And so now the second one. Second one is calcium. Now calcium reacts with the water in the same way. But the thing with calcium is that the reaction, it's going to form calcium hydroxide plus H2 gas would be produced, but the reaction is not that vigorous. It's a it's a slow reaction with cold water, and there's going to be slight effervescence. Like there's going to be hydrogen gas, but not that vigorous. Um, and then you move to magnesium. Now the thing with magnesium is that when you reach magnesium, magnesium is very unreactive. I mean, its reactivity is now lesser. You're going down the group, so the reactivity is decreasing. So what Mg does is it doesn't react really with cold water. It actually reacts at high temperature with steam. So reacts with water at high temperatures, reacts with steam at high temperatures. And very, very slow reaction with cold water. Achha, one thing about the pH as well. In the first one, remember always a strong alkali is produced. Like NaOH is very soluble. Achha, but magnesium oxide is going to be, it's not very soluble. If you know the solubility table, MgO is not very soluble. It's a base, it's a metal oxide, it's not very soluble. So very slightly alkaline solution because it's not going to mix with water and it's not going to produce a lot of OH ions. So very slightly alkaline. So group 1 metal they form strong alkalis. If you remember the solubility of hydroxides, then group 1 was soluble. Group 2 के अंदर the bottom ones were soluble, not magnesium. So let's move to aluminium now. What's the case with aluminium? Now the thing with aluminium is that aluminium absolutely has no reaction with water. Has no reaction. Whether it's slow or fast, it absolutely has no reaction with water. And so why doesn't it react? TK, you'll be asked this a lot. The reason aluminium doesn't react is that if you take a piece of aluminium, the reality is that it will actually react, but only the top surface. And the top surface quickly forms aluminium oxide. And that aluminium oxide completely surrounds the aluminium and protects it. and it prevents further reaction. Like once the layer of aluminum oxide is formed, the water molecules would not be able to reach aluminum because there's a layer that is protecting it. So the water molecules will hit the layer and will bounce off. So they wouldn't be able to reach aluminum. So the reason for that is that the reason is that the unreactive non-porous layer of Al2O3 and non-porous layer of Al2O3 protects aluminum from further reaction. Non-porous means that nothing could go past this. So aluminum quickly develops this, and it's a very shiny layer, which is why aluminum doesn't rust. ठीक है, you make windows and doors out of aluminum. Uh, even वो जो rails होती हैं, क्या कहते हैं उसे, walls वगैरह कहते हैं, pretty much all the वो hand railings etc. They're made from aluminum and they don't rust. They remain shiny. ठीक है, is this clear as well, Hamza? Is this clear, Rafe?
Sir,
Yes, sir.
हाँ जी.
sir, अगर question है कि why does not check तो हम लिखेंगे Al2O3 is formed that protects us from further reaction.
हाँ, exactly यही लिखोगे. The unreactive and non-porous layer of Al2O3 protects aluminum from further reaction. ठीक है.
Okay.
अच्छा, then you have अच्छा उसके बाद नीचे जाते रहोगे, the reactions would become slower and slower. The bottom ones, they're not no reaction with water. ठीक है. Maybe after 10,000 years or so, but no reaction with water. ठीक है. We can assume that they don't react with water. They're so unreactive. For example, gold. Nothing would happen to gold. अच्छा, and as you go lower down, the reactions would eventually slow down. So you started off, I say you started off with the most reactive ones. They were reacting explosively, group one, and then you kept going down. Apart from aluminum, that's an anomaly. The others they started reacting slowly and slowly. For example, take iron. Iron को पानी में डालो, so it takes years for it to rust. ठीक है, Titanic जो है that has sunk like hundred years ago, and it's still there, which means it hasn't reacted completely with water. So, well, rusting is a very slow process. So we're not going to discuss rusting of iron. That will be discussed in a bit more detail now. Okay, so we're going to talk about iron now. And remember, the reaction with water of iron is very slow, which is why you make cars out of iron. Okay, you make cars out of steel because you know they're not going to rust like in 1 year. Probably some rusting might happen after 20 years, uh, but the reaction would be very, very slow. Acha, so let's talk about rusting. Okay, let's talk about rusting of iron. Now, rust for iron is it's the red compound that is formed. ठीक है, which I can बोले वैसे तो सारों को पता है कि what is rust. Uh, but here's the example. कि it's the red or orange compound. पता नहीं क्यों नहीं नजर आ रहा. ठीक है, it's the red oxide that is produced. ठीक है, on the surface, and it falls away. Powdery सा होता है. It's not like aluminum oxide. Iron oxide is like a powdered substance which starts to corrode and slowly breaks down. तो वो जो पिछला था ना aluminum oxide, that was very tough and it was non-porous. Non-porous meaning कि nothing could go past it. So rusting of iron is कि it's basically iron reacting with oxygen to produce Fe2O3, or it's basically iron reacting with water to produce Actual equation is this one. So it's iron reacting with oxygen and as well water as well to produce Fe2O3 or FeOH3. ठीक है, iron 3 oxide or iron 3 hydroxide. Now for rusting to happen, this is the red brown rust that is going to be formed. And it corrodes easily. मतलब पाउडर सी चीज होती है तो it quickly falls off. तो आपका जो metal होगा ना that would become hollow after some time. अच्छा, so what are the essential conditions? Essential conditions are okay, if you want things to rust, you need two things. You need water and you need air. And by air we mean oxygen gas. Okay, so a combination of water with oxygen gas, that is what is going to cause rusting, and that would speed up the process. So humid environment के अंदर ना usually rusting happens a lot. For example, if I mean cars in Karachi would be rusted because there's too much moisture there, and warm conditions के अंदर भी ना rusting ज़्यादा होगी. अच्छा, but anyways, these are the most two important conditions for rusting. अच्छा, the important point is how do you prevent rusting? किसी को कोई idea? Any idea कि how do you prevent rusting?
सर lubricating oil यूज करें.
ठीक है. So one is number one, machines वगैरह के अंदर यही होता है कि you lubrication यूज करते हैं. Oil, cars को आप wax करते हो. How does that prevent rusting? Anyone? कार को wax
It
करने
does
से
not let oxygen.
क्या?
It does not let oxygen to react.
हाँ, क्योंकि वो एक कोटिंग बन जाती है ना, मतलब ये आयरन का पीस है, तो उसके ऊपर अगर वैक्स लगाओगे तो there's going to be a coating of wax या oil on top of it. ठीक है, so let's say this is iron and that is the wax that's on top of it. Just 1 second, board hang कर रहा है, एक second रुको. Just 1 second. अच्छा, so ये आयरन का पीस है और इसके ऊपर आप क्या कर रहे हो, यू बेसिकली कोटिंग इट विद वैक्स. तो उसके टॉप के ऊपर ना वैक्स लग गई है, अंदर आयरन है. अब एयर और वाटर जो है ना वो पहुंच नहीं सकते उस तक, मतलब ऑक्सीजन एंड वाटर would not be able to come close to the iron. ठीक है, so the layer protects iron from air and water. ठीक है, ये क्लियर है?
Yes, sir.
हमजा क्लियर है?
Yes, sir.
राफे? अच्छा.
Yes, sir.
Acha, but the thing is, it's not a very good way of actually preventing rusting. For example, if you have a car, you have to wax it a lot. So that is time consuming and it's not very खास तौर पे if the metal object let's say if you have a big bridge, तो एक तो मसला ये है कि वैक्स वगैरह ऑयल वगैरह ये उतर जाता है, ठीक है, थोड़े टाइम के बाद it's a liquid substance, it falls off. ठीक है, कार आपकी वैक्स कितनी देर रहेगी, it's the wax is going to disappear eventually. तो लेट्स से यू हैव एन आयरन ब्रिज, तो उसको क्या करोगे? चलो कार का ही बता दो कि उसके ऊपर और कौन सा तरीका यूज करोगे जो थोड़ा परमानेंट हो, क्योंकि ऑयल वगैरह लगाना वो तो बार बार लगाना पड़ेगा ना, जैसा साइकिल की चेन को आप बार बार ऑयल लगा रहे होते हो. The second
So
one is, huh?
car
TBS,
paint.
ठीक है, paint कर दो, ठीक है, that's paint is slightly more permanent solution. You paint it, लेकिन paint का मसला है कि खास तौर पे वहां पे जहाँ पे फ्रिक्शन होती है, जैसा वो चेन है, चेन को पेंट नहीं कर सकते, वो पेंट उतर जाएगा, वहां पे ऑयल ही लगाते हो, ठीक है. अच्छा, so अच्छा, paint does the same thing. It provides a coating and it prevents rusting. अच्छा, उसी तरह ना you can coat it with a lot of things, ठीक है. Number 3, you can electroplate the whole thing with electroplate with let's say with gold or silver. So if, for example, watches get electroplated, so same concept. Gold is a very unreactive metal, so uske upar if the coating is done, uh, so the iron will be protected and it will look good as well. So तीनों तरीके हैं, same concept. You just coat it with either wax, or you paint it, or you can coat the thing with silver or something shiny, something unreactive. The iron will be protected, right? But all three have this problem. All three have this problem, and that is 1, 2, 3 have the problem that if the layer disappears, which it easily disappears. Okay, for example, the gold plating could get scratched off. The silver plating could get scratched off. The paint can be scratched off. Uh, and the same is for waxes. Waxes, they kind of wither away and they evaporate. So both 1, 2, 3 have the same problem, that the coating can be easily scratched off. फिर उनके मेंटेनेंस बड़े इश्यूज हैं कि बार बार पेंट करो, पर पेंट करना, I mean, painting things is not easy, ठीक है, especially if the object is huge. So let's say you have an Eiffel Tower. अब you can't really go painting it कि every time आप इंश्योर करो कि कहीं से पेंट ना उतर जाए. That's kind of very tedious and very expensive. उसको वैक्स करना शुरू कर दो पहले, that's impossible कि आप आईफल टावर को वैक्स करोगे. और electroplate with gold or silver, that's out of the question, ठीक है. Uh, so how do you prevent rusting if the object is big, like an Eiffel Tower or a ship? कोई आइडिया नंबर 4 क्या होगा?
So sacrificial protection.
ठीक है, the last one is sacrificial protection, which is a more technical way of protecting instead of the first three, also known as galvanizing. Now, what you do in sacrificial protection is that you take a piece of iron, and you don't even have to coat it. What you just have to do is you have to make an electrical contact with a piece of a slightly more reactive metal, which is usually zinc, or it could be Mg as well. ठीक है? Now it could be coated as well, but it doesn't have to be a coating. ठीक है? It has to be just an electrical contact. Some electrical contact might exist. Like you can attach a piece of zinc, a small piece of zinc, to a corner of iron. That would also work. Actually, now what happens is zinc is more reactive. So if it's more reactive, what does that mean? It means that it likes to lose electrons. ठीक है, metals में यही है ना. Remember this, metals के अंदर यही होता है कि if a metal is more reactive, it really likes to lose electrons, right? तो iron और zinc में कौन ज्यादा electron lose करना चाहता है? Zinc. So zinc जो है ना would start to lose or produce electrons. It's going to start losing electrons. और zinc ions बनना शुरू हो जाएंगे. खैर, the electrons would be lost. And the electrons have no place to go, so they would just travel through the electrical contact and they would also appear on the iron. So zinc would start providing these electrons to iron because zinc is more reactive. It likes to lose electrons. Achha, what would the electrons do over there? What they would do is, if there is oxygen and water, now these are non-metals. मेटल के साथ किस तरह रिएक्ट करते हैं? आयरन इज द वन दैट्स गोइंग टू लूज इलेक्ट्रॉन्स टू ऑक्सीजन. ठीक है, रस्टिंग इसी तरह होती है ना. If we would lose electron to form iron, and oxygen would gain electrons to form an iron. ठीक है, Fe is going to give electrons to oxygen. Ionic compound बनेगा. ठीक है, rust is an ionic compound. Iron is a metal, it loses electrons, and oxygen is the non-metal which gains electrons. And together, this forms a positive ion, this forms a negative ion. So one forms a positive ion, the other one forms a negative ion, and they form an oxide. ठीक है, they form an ionic compound. So पहले क्या हो रहा था? Iron was the one that was losing electrons, getting oxidized, and oxygen was the one that was gaining electrons. याद clear है सारों को? Aris, is this clear? Noor, clear है?
सही इलेक्ट्रॉन जाने से पहले हुआ है ना ये?
Yes, sir.
हाँ. अब
ठीक है
ये
सर.
कि मतलब पहले लेट्स से जिंक नहीं था ना, तो ये वाले पिंक वाले इलेक्ट्रॉन्स मैं हटा देता हूँ. अच्छा, पहले क्या हो रहा था? आयरन इलेक्ट्रॉन लूज कर रहा था, वाज गेटिंग ऑक्सीडाइज्ड, एंड ऑक्सीजन वाज द वन दैट वाज गेनिंग इलेक्ट्रॉन्स. तो ऑक्सीजन आ रहा है, इट्स अ नॉन मेटल, इट लाइक्स टू गेन इलेक्ट्रॉन्स, राइट? तो लेकिन अब जिंक के साथ जब ऑक्सीजन आ रहा होगा, तो वेयर आर द इलेक्ट्रॉन्स कमिंग फ्रॉम? जिंक से आ रहे हैं ना.
यस सर.
तो आयरन को फिर लूज करने की जरूरत नहीं पड़ेगी, और आयरन के आयंस नहीं बनेंगे क्योंकि जिंक इलेक्ट्रॉन्स भेजी जा रहा है. सो इन द प्रेजेंस ऑफ जिंक, इसको डिस्क्राइब भी करना होगा. तो इन द प्रेजेंस ऑफ जिंक, electrons that are gained by oxygen, they indirectly come from zinc. As zinc has a greater tendency to get oxidized. A greater tendency to lose electrons. So as it is more reactive, an electron travel from the zinc to the iron. Hence, iron is not oxidized. तो Fe जो है ना, वो फिर इलेक्ट्रॉन्स लूज नहीं कर रहा. इन द प्रेजेंस ऑफ जिंक, इलेक्ट्रॉन्स आर गेन्ड बाय ऑक्सीजन, indirectly come from, इसको सही कर लो, indirectly come from zinc. ठीक है, ये सारा क्लियर है सारों को कि
Yes, sir.
iron would not be able to lose electrons in the presence of zinc, क्योंकि zinc has an even greater tendency to lose electrons. Zinc फेंक ही जा रहा है electrons iron की तरफ, तो iron would in no way be able to lose its electrons. तो अगर oxygen gain कर रहा है electrons, all those electrons are basically coming from zinc indirectly. और zinc का पीस ना खत्म होता जाएगा. Zinc would be the one that would be reacting, not the iron. ठीक है, is this clear to everyone? हमजा clear है?
Yes, sir.
मरियम clear है? अच्छा, लास्ट जो है ना, दैट इज के नंबर 5th, वो इसी तरह, दैट्स नोन एज कैथोडिक प्रोटेक्शन.
सर
कैथोडिक
इसमें zinc खत्म नहीं हो जाएगा?
खत्म हो जाएगा ना, तो आप दोबारा पीस लगा दोगे जिंक का. मतलब आपने आईफिल टावर के को ना एक उसके साथ टच किया होगा, जिंक के ब्लॉक के साथ, तो आईफिल टावर रस्ट ही नहीं कर रहा होगा क्योंकि वो उसकी इलेक्ट्रॉन लूज करने की बारी नहीं आएगी. अच्छा, लास्ट वन is cathodic protection. That's pretty much the same. Now in cathodic protection, what happens is what you do is कि जो भी चीज है उसको आप ना उसका बैटरी के नेगेटिव टर्मिनल के साथ अटैच कर देते हो. ठीक है, लेट्स से there's this shipping rig in the sea. तो आपने ना उसको बैटरी का जो नेगेटिव टर्मिनल है उसके साथ अटैच कर दिया. व्हाट हैपेंस इज कि नेगेटिव टर्मिनल इलेक्ट्रोलिसिस हमने पढ़ा था, तो उसके अंदर क्या होता है, बैटरी नेगेटिव टर्मिनल पे इलेक्ट्रॉन्स भेज रही होती है. तो वही कॉन्सेप्ट है, आयरन यहाँ पे बैठा है, ऑक्सीजन आ रहा था और वाटर आ रहा था उससे इलेक्ट्रॉन गेन करने, कि वो उन्होंने कहा था, उनका प्लान था कि जी आयरन के पास आएंगे और इलेक्ट्रॉन्स गेन करेंगे. तो इफ यू मेक आयरन द कैथोड, ठीक है, वो जो भी ऑब्जेक्ट है उसको इफ यू मेक इट द कैथोड, तो ऑक्सीजन को जो इलेक्ट्रॉन्स मिलेंगे वो आयरन की तरफ से नहीं आएंगे, वो उल्टा बैटरी इज द वन दैट्स सेंडिंग दोस इलेक्ट्रॉन्स. आयरन की लूज करने की बारी नहीं आएगी, वहां से इतने ढेर इलेक्ट्रॉन्स आ रहे हैं उसे लूज करने की जरूरत नहीं होगी. अगर वो लूज गलती से कर भी लेगा ना, उसको बैटरी और इलेक्ट्रॉन्स भेज देगी. तो आयरन वुड रिमेन प्रोटेक्टेड, इट वुड नॉट बी एबल टू फॉर्म एन आयरन. ठीक है, इट वुड नॉट बी एबल टू लूज इलेक्ट्रॉन्स. इवन इफ इट लूजेस इलेक्ट्रॉन्स, मोर इलेक्ट्रॉन्स आर गोइंग टू कम इन फ्रॉम द कैथोड. तो यू गोइंग टू टेक द पावर सोर्स, and if anyone tries to gain electrons here, those electrons come from the battery. So that is cathodic protection. तो इसमें क्या, electrons gained by oxygen or water, this time indirectly come from the battery or the cathode. ठीक है, is this clear as well?
Yes, sir.
तो ये पांच तरीके याद रखना कि पहले तीन जो है वो छोटे लेवल पे तो काम कर जाते हैं, बड़े लेवल के अंदर उनका इशू है कि पेंट कर लो, लुब्रिकेशन, इलेक्ट्रोप्लेटिंग, उनका मसला है कि वो स्क्रैच करोगे ना तो रस्टिंग शुरू हो जाएगी. इसका फायदा ये है कि इसमें आपको पूरा कोट करने की जरूरत नहीं है, बस इलेक्ट्रिकल कांटेक्ट चाहिए, एंड दैट वुड प्रिवेंट आयरन फ्रॉम लूजिंग इलेक्ट्रॉन्स. ठीक है, चलिए यहाँ से हम कंटिन्यू करते हैं कल. ठीक है, चले, ओके देन, टेक केयर.
Allah Hafiz.
Allah Hafiz, sir.
फिर